Hey everyone, it's Ankit here. Welcome back to Planet Dev. In the last video, we started building web APIs in Golang. If you missed it, don't worry. I have pushed the code to the GitHub repo and the link is in the description below. Today, we are going to take it a step further and focus on parsing JSON request bodies and validating those requests. Trust me, this is super important because in real world application, you should never trust incoming data from the client side. So let's not waste any time and jump right into it. Let's create new branch and start it over here. Git checkout main, git checkout branch chapter 2 and open it in our editor. In the last video, I'll just give you we have just built our server application and then putting up some routes over here. And now we are working on our sign up handler. Now to read the request body, we have a couple of ways. One of them is your request body will be available on r.body. And once you consume this one, it is a buffer. If you see the type of this, it's a read closure, and which is a buffer kind of body you are getting. You have to read it and then you have to close the body. What you can do is you can read it from any of the reader, and one of the reader is io.readAll. This you can pass and then read your body request.body. This is one way. The another way is you can have your JSON and decoder, decode your JSON and then you will be reading it and parsing it to JSON. So we will be as we are dealing with the APIs, we will be expecting a JSON input, and that's why we won't be reading it with using the read all rather than using the JSON decoder. So let's create a function for this, and then we will pass our request body to that function and read it over there. Let's create a new file under server. Let's create a new file, say utils.go, and package would be server only. Let's name the function as parse request body, and it is expecting a request object to be over here, which would be a pointer to http dot request object. And we are also expecting a result where we want to write our read body. So the result, it could be of type any. We can also return an error. In case we are not able to read the body, we should be returning an error. So now to read the body, we have this body, r.body. Now, as soon as we read the body, we should be closing this body whenever our function exists. Even in case of error happens, this should get closed. So to do that, we can use our defer.requestBody.close. So this will get run anytime this function is getting returned, whether in case of error or just in a successful case. So this body will be get closed. One thing I just want to tell you over here, whenever we are reading a body, it will be read and it won't be available further on from the request.body. You will have to put it back again if you want to reuse it further. But in our case, like when we are reading it on our handler function, we don't it required to be available on further over there. So that's why we don't have to put it over there. If you're doing it in the case of middleware, let's say you want to read the request body and put it into the logs, then you will have to read the body from your IO reader and then put it back again to the reader to the request object. So we will be doing this in the middleware further on, but for now we just need to read the body and let's consume it. Now we'll be using JSON decoder and put the request body over here. And we also do not want to have any unknown fields to be available to us. That's a good point from the security point of view. We should not allow any other properties which we are not expecting. So we'll be disallowing all those properties. And then decoder.decode and put the results into the struct or the results variable which we have got. Then it will read the body from the bytes and convert into a JSON and put back all those results into the struct it has been passed over here. It will be returning an error. We will have to handle the error as well. So in case of error, we will be simply returning the client. Like if their error is not nil, then we will be simply returning the error with fmt.error format, failed in parsing request body, and we'll append the error as well. In case it has read the body, we will be simply returning nil. Yeah, that's pretty much. There's one more thing which we can handle over here is if the body is like completely empty, then also we should be, if the request body is equals to nil, then also we should be returning some error. And for this, you can simply return an error with creating an error as errors.new, name it as empty underscore body. Instead of defining it at the runtime, we can define the error code at the time of initialization itself. So error empty body equals to errors.new and simply return that error wherever required. That's pretty much. We are ready with our parse request body function. We can use it over here, and we need to pass request object, and we should be expecting an error over here. So we need to call it from the server package, server.parse request body. In the second argument, we'll be passing the reference of the input type, what we will be defining for the sign up handler, which can be input and a reference to that particular object, because it has to overwrite the data. Then that can be done only in case we will be passing the reference over here. So input would be of type sign up request, and this will be defining over here. Let's say type of sign up request struct, and here we'll be defining the signatures of this particular request body. So what we are expecting in the request body, we will be defining here. Let's say we want name of type string, username of type string, email of type string, gender of type string, and then date of birth of type string, then let's say password of type string, and confirm password of type string. Yeah, this should be good enough for us. And this sign up request we are passing over here. Now we should be also handling, like in case of error returns, if error is not equals to nil, that means there is something wrong with our request. We will be simply returning the http.error and passing our writer object, the error string, which would be, let's say, bad request, and the code would be http.bad status bad request, which is 400. Now, if we don't get an error over here, that means we have successfully passed our request body. So let's create a user object and we will assign the same values to there. Further on, we will be like doing some other validations on this particular object, and then returning, saving the user to the database, and then returning back like what we have created. So over here, let's create a type as user struct, and we'll be having very similar fields. Let's copy this from here itself. We won't be having a confirm password because that's not required. We will also be having an ID field over here to create a unique ID for the user. And let's put all these values, whatever like we are getting from the start, from the input, we will be passing it to the user. User of type user, and let's assign those values. We can like fill the user by all of this automatically. And for ID, we need to create a random UUID. And for other fields, we can just simply do it by input dot name, input dot username, input dot email, or otherwise I can do simply copy this input dot the name of the field. And now we have the user is available with us. We will be simply putting it to the data object and send it back. On this response. Instead of status, I would like to pass a code kind of like response, and that could be, let's say, success over here. So we are sending a success response code for this particular response. It says an error because we are reinitializing over here, so that's not required. And that's pretty much for ID. What we will be doing for ID is, let's use another package from the Google of generating UUID and then reuse that. Go UUID. And yes, we will be using this particular package. Go get this package. All right, we have added this particular package. Let's create a utility function for this. We will be creating this into a separate package because that is a reusable kind of package. Let's name is set package and then maybe randomness. And over here we'll create our file as uuid.co. Package name would be randomness, and function let's create as generate uuid. What it will do, simply uuid package dot new, and what does it return? A uuid format. uuid equals to this, and then we can convert this uuid to string and return it. So we can add the signatures as string to be returned from this function. Let's name it as new random ID. Better. So here we will be using our randomness package from what we have created and get the new ID. Let's try this out. Run the application, go run main.go. There is some cyclic import is not allowed. Okay, we are getting this error. This is an auth package. We are importing the package from the server itself. Okay, that is because we are using this package over here, and this auth package we are putting into over there. So we should not be defining this over here. Instead, we can define into a separate package, because also this is a reusable package. Let's define in our package directory itself. Let's name it as HTTP utils, and under this, let's take it name as a with respect to requests only. Request utils. Copy this entire file and put it over here. Delete this particular file. From the request, we will be changing the name of this package, which is HTTP utils. Now over here, we don't have to import it from the server's package. We can import it from the HTTP utils defined from our package system. Yeah, now we should be good. Let's run it back again. Listening on port 3000. Let's go to our HTTP and let's see. All right, we are getting a bad request and also a response, and that is because we are not returning when we have got the error. So we should be returning from here itself if we got a bad request. And we were not closing it also. Yeah, now we should be good. Let's rerun and try it out. Yeah, now we are getting the proper bad request as an error and the status as properly. If we pass the request body properly, we should be able to get the response as user created. Now success, and the new user ID has also been created and the username which we are passing. But now it does not validate the data. So next thing, we need to focus on the validating our data. Like we are passing only the username, but we have other required fields also. Email should be present and the password should be present. All those things should be present, and then only we should be able to register our user. Otherwise, we should not register the user. So to validate the data, we will be using another package of go-validator. Let's get that first. Go-validator. Yeah, this particular package we will be using. Let's grab that go get command and add it to our project. This is a pretty good package. Like it has quite some, like 17,000 stars. So it's very popular among the Go community and it's widely used. Now to validate the request body, what we have passed over here, we'll be passing it to the validation function. So we can expect the APIs for this validation could be something like uh, a function which says verify, and we'll be passing our input data. What it will be returning is validation errors. So validation errors, it will be returning to us. And in case of errors we got, then we will be simply returning it back to the user. And if it is everything is goes well, then we'll be returning the success. So to create this particular function, let's create into a separate module, name it as verifier, verifier.go. The package name would be verifier. Next, we need to create our validator for the library which we have just imported. We'll create a object for this. Let's say verifier, and which will be equals to the validator which we have imported. So validator.new, and what options it is expecting is validator dot with private field validation and with request struct enabled. With private field is not required for us because we are not defining any private fields, but with required struct field enables, that is required because one thing is it will be a default behavior from the version 11. Now to use this particular validator, we will be creating a function as a validate struct. It can have a data of type any because you can pass any object you want to validate, and then it will be returning a type of error. It is very simple. Like from the verifier, we can simply verifier dot struct pass the data. It will return us an error. If it does not have any error, that means we have validated successfully. We can simply return nil. But in case the error is not empty, it's not nil, that means we have something to do over here. We have to check for the errors and then return it back to the calling function. So return an error from here. So we have the package as a verifier dot validate struct. And the data we are passing it as a input. So now if we have got any errors, if validation error is not equals to nil, then again we will be sending a response back to the user saying that something went wrong, like you have sent a bad request. So let's copy paste in this one, that bad request, and otherwise we are good to go. We have not defined our validation rules as of now. Let's define the validation rules as well. For any struct field, we have to define the tags. We have also not defined the tags for our JSON fields right now. Let's define that as well. I'll explain like further on why is that required. So JSON and the name of the tag, what we want in the JSON response. So whenever your Go struct is being converted to JSON, this, if you're not defining it, it will be taking the same name as it is. But in Golang, we have a rule of capitalizing all those exported fields, but if you name it as a with a small letter, it won't be exported. So if we want to export it, we have to name it in capital, but in JSON formats we usually don't follow the name to be capitalized the first letter. So your JSON APIs will have a smaller or different name it could be. So to map that particular thing, we have to define the tag as JSON and call it as name. The second thing which we can do over here is to have the validation rules. So to do that, validate and the validation rules which you want to like apply. For example, over here, I will be typing a required field. And this, we can also put some other validations like the minimum characters should be 3. So for others, we will be simply doing it in a faster way. Let's do it, copy this, and JSON name would be, I'll say, lower camel case. I converted all the values to into this. And then we will be also defining the validation rules for these, which can be done by validate. And then let's see, I'm putting all of them as required. I'll be marking some of them as non-required. Let's say gender is not required, so I won't be putting it any validations for that. We can say optional. We don't have to provide the space over here, so we can just remove the spaces from here. That is not required, like that's an invalid syntax. From the password, and the confirm password should always be equal. So on the confirm password, I can give a rule as EQ field equals to password. This password should be matching the name of the fields exactly, like P should be capital, so P should be capital over here. And other things like in the password, I can give like minimum character should be, let's say, 6 or 7, and the max should be equals to, let's say, 20. So this much maximum length of the password you can give. For email, we can have a validation rule as email. So all those rules are being defined over here. Like you can go to the repository and see what all the rules available for you. So you can see the email rule is already over here. You can also see equal field is also there. You have other fields also like similar to this. You can also comparisons also, like if greater than or less than kind of like things you can have. So go through this list and then apply the validations rules which are available for you. So let's try to verify by running the server and hit the request. Oh, like we are getting an error as internal server. Something went wrong. We did something. We messed up. Yeah. Yes, we messed up, and what we have messed up? Undefined validation function optional. Okay, optional is not there. How can we do the optional? I don't know. Okay, is there anything for the optional? No, it's not there. Okay, we can just simply skip that instead. Does that allowed? Let's try that out. I don't know about this optional. So let's try this out. I think this should also fail because we have defined it. Don't allow anything, like the validation should be required. So let's try that. Okay, it says bad request, but what is the error message? We won't be getting that. So we have to print that error message as well. How can we do that? Okay, we will be going to this particular validate struct and see what our error message says. We'll be printing the error message and then converting it over there. So this validator is providing us two kinds of error messages. One of them is like invalid validation errors. That means if something wrong with this validation, the struct itself, then that will be captured. And then there is a validation on the rules. So if the rules get failed, then we have the validations kind of errors. So to capture that, what we can do is we will be converting this particular error into that particular type of error. In Golang, what we can do is error dot and the type casting, which we can do over here. We have to do using validator dot invalid validation error. That means something went wrong with the struct itself. So in case if this got success, we will be getting an error message exactly like what has happened, and then we will be also getting whether this has been converted successfully or not. Yeah, of course, like we need to assign these values. So if we have got this particular error, like we'll be putting into an if condition, and if the OK is true. So this is a shortcut in Golang that you can assign the values and then recheck on the same thing on the same expression itself. This error we are just overriding over here, that's right, and which is actually not so required because we know that this is invalid. is ignore that particular thing and then return the error from here itself. Now to return the error, what we can do, we can define our error dot new and then pass it over here, invalid request body. This I can do, but this doesn't give me a flexibility of passing the error message as well as the data from this particular validation, because further on we will be checking what type of validation rule has been failed, how many of them are getting failed. So through that, better let's create our own type of error validations. So to create that, we'll be creating a struct error validations. Let's say type error validation, and it will contain a message which can be a string, and then details which can be of type map of string, and which has the values as a string as well. Now to convert this particular struct, like to follow this particular struct, or you can say implement the interface of this error object, we have to create a error function and assign it to a receiver function of that struct. So let's create function which will be having a receiver function of error validation and name it as error. So whenever on this particular object error, if we do like percentile w or something, like we want to print this particular error message, then this particular function is get called. So we need to convert our this particular struct into this format. So to do that, we will be simply returning the message only field, like ev dot message, and then we should be good. We have not defined the function parenthesis, and it will be returning a string format. So now we have this our own error type of error validation error, and then we can just simply return this. Now here we'll be defining only the message field because that's only we have. We'll say invalid request body. Next, we need to capture all the error messages for each of the validation rules which are being applied. So to do that, we need to convert our this error message like type check based on the validation error. Now, earlier we have type checked on this particular error message, like if the error is of type this one, then return this one, otherwise proceed further. Now, if the error type is of, let's say validator dot validation errors, then this will be converted to that particular error object. So again, we will be checking whether, let's name it as errors and the value as okay. Okay means that means like we have typecasted successfully. Now, if we have got the errors, like let's say if we have okay is available, that means we have successfully casted into errors. If doesn't, that means this error is of not that particular type. So in case of okay only, we will be moving it further. Otherwise, we'll be simply say we don't know what's the reason. Return invalid request body, but we don't know like what went wrong over there. In the details, we can simply pass it, not details, but we can have a row error kind of thing over here. Let's see, row, and which will be of type error. And here also we can just simply pass the error. Like if we, in case we need to do anything on that particular thing, then we can do error of error. Now, if we have converted this errors into a validation errors, what we can do is we can run a for loop on this particular range of errors by doing, so the first element would be an index, so that's why we don't need this. The second object which we'll be getting from this errors is the one particular error out of all many. This is for the ignorance. Like if we don't need any very particular variable, then we can simply mark it with the underscore. And over here, let's create a temporary variable of validation errors, and this we can name it as a using of make, and that is because we will be like putting the values we and for this particular map, like at the time of runtime of this for loop, so we should be having a defined capacity of this slices. So to do that, we can just take the length of the errors which we have already got. So in this case, we have created a slice of this map, and the capacity is number of errors which we have got. Now over here, we can just simply put the values over there. So against each of the field name, we can put the error message what it has got. So e dot field equals to the error message for it. We should be like iterating over the range, not just like errors. It should be a range, and then we will be good. All right, let's print this message also, like just to know what we are getting, and the actual messages fmt.print. And then in each line, we'll be printing the first thing which we can print is e dot the field name, and then the value for this, what's the error of that particular field. Once we have all the errors available to us, then we can simply return the error message, which is error validation struct. And over here, our message would be invalid request body. And in the details, we can give all the validation errors as well. Now let's use this particular method in our service over here. So we are getting the errors now. If it is not equals to nil, then we are sending this particular error message. Now to send all the messages into a JSON format, we should be sending it to this particular kind of like format. And now we are sending, like, there's some quite of code like over here. To reduce the boilerplate code, like we will have to put over here also the same thing, which looks a bit messy to me. And to do this in a better form, what we can do, let's remove this first over here and create our result object, which would be result of map and string of string. It can have the code as a response, which can be, if it is a validation error, we can have, like, we can predefine these error codes in somewhere, then we reuse it. But for now, let's say validation underscore error, and then we can have data, and then we can also have a message field over here. So now to define these things, we have to do it from there. But now, right now, we are just returning an error object from there. We can either typecast into a particular validations, like if we have got that particular error, now it will always be returning an error validation. So in that case, what we can do is we will be returning an error of type, let's say error validation itself. So in that case, we will be having a clear idea about this one, that we are getting a validation error only. So to do that, we can simply return the details field over here. Of course, like this should be any type, and then we can have validation dot message, and then return it from here. This particular thing I'm not really liking, so let's move this particular thing also to a particular function so that we can reuse this. We can put it over here itself, like in our request package, name it as function send JSON response. What is it expecting is the writer, which is http.response writer, and it is expecting the data field, which could be of type any, and we'll be simply passing it to over here. In case of error is coming over here, if error is not equals to nil, then we can simply return it as a http.error, and which could be a default error message, like something went wrong, or maybe you can say internal server error, and the code will also be internal server error, and then return it from here. This should be defined. Error is not equals to nil. Otherwise, we are sending the data from this our encoder itself. Like we are passing our writer like this. This will encode the data into JSON and write it to the writer what we have provided. And that's pretty much. We don't have to return any error from here. Now we will be using the same from our HTTP utils from our package and send the JSON response with the data that we have created. Same thing which we can do it over here also. We don't have to do it now ourselves. Simple, easy. Let's test this out and see. Undefined string. Oops, some typo I have done. Yep, this should be string. Let's rerun and see if we have made any blunders. All right, let's test it out. Okay, we have got now a data with couple of rules validations and the code says validation error and the message says invalid request body. What it says, confirm password, like it's not matching. Date of birth is required, but we have not provided. The email also, it's required, but we have not provided it. But these messages doesn't seems to be very much readable to the user or to the API consumer also. So what can we do for that? Yes, we can do, of course, something better. Our go-validator package is providing us a validation translations also. So it has some inbuilt translations available for multiple languages. Then these messages will be converted into that. You can also define your own custom validation messages as well. Like if you want to provide some validation message for your name field, like you can say, please provide your real name. So you can have that particular error message defined in your translations. So let's do that. To create the validation translations, we have to first create our a translator, which we can do by ut, like import this particular package, universal translator, and then we will be defining our translator for the language English, where translator, which will be of type ut, which is universal translator, and then type as translator. So this package is within the same validator package itself. And the next we will be loading our locals and the translation messages. And we can load it on our verify struct method itself, but that wouldn't be a good ideal place to load the error messages, all the translations available for all the rules and the locals for a language. The good place for this initialization would be into the init function. Golang is also providing, similar to main function, we have a init function which does run at the time of initialization of a particular package and in a particular sequence which is being defined. So if you talk about this particular file, over here, these two lines will be run first, and then our init function will be running. If you have a main function in your file over here, function main, in that case, like you know that main is run first time, but if the init function is defined before this one, then the init function will be running first only. So over here, we will be initializing our locals. What we can have is local. We need to find the en local. That means the English locals. What you can have is en.new, and then it will be assigned to you. English is equals to this. And then we'll be putting this particular English language into the translator, which we can do by ut.new. And here we need to provide the locals. So in the locals package, what it contains is language locals for converting a word to like singular to plural, or it has currencies for different countries. It may also have your week's name or month's name. So all those things will be available in your locals package. And the actual translations for your error messages, for example, we have a tag as required. So these tag particular message is defined into the validator's translation package. So that will be importing after this. So we have the English translation locals over here. So this is a fallback, and then again we have to provide the what options does it have. You can have as many as locals available. You can define it for other languages like French, Spanish, or Hindi, any language you wish to have. Those packages are also like available just after the locals. You can have for French, you can have for Spanish, you can also have it for Hindi. So for now, we are dealing with the English language only, and assign it to a universal translator because we will be using this one to further. Now we'll be using this one to get the actual translator, which we'll be using to translate the messages. So let's do that with the translator of language. Let's say English is equals to universal dot get translator and the name of the local, which can be en. It returns a two variables. One is the translator and the another is a found variable. So we can define a found over here and the translations. So now this variable is already defined. We wouldn't be like in this particular scope we are redefining it, so it will override that particular value. So instead of that, we should be just reusing this one. So we should be just assigning a value, and this found variable is only to this scope. So we can just create a variable as found, which of type boolean, then reuse it. So now here it will return the value of translator and will be added over here. And now we need to check whether we have actually got the translator or not. If we do not found this translator, in this case we can just panic it out the application, which can be done by no translator found for language English. What I'm filtering over here. So far we have loaded our translator, but we have not mapped our translations to the verifier or the validator, and we have not loaded the actual validation translations of this rules which are defined under the validator. So to do that, we also need to get the translations of the rules. So which we can get it from the validator package. From this, we can have the translations available and then the language name. Let's name it as English translations. And then from this particular thing, what we can do is register our default translations for the validator which we have defined. So this will be the verifier and the translator which we have got from the universal translator. So this is basically a glue between our verifier, this validator, and the translator, the locals which we have loaded, and the translations from the validator package. Now this will also be returning an error, and we need to handle the error in the same way we can just panic it out if it is not able to map all the things together. So panic, say cannot register default English translations to the validator. Yeah, that should be good enough. Now we have the validations attached. Everything is being done. Now we can simply use this our translator while translating our messages. So now instead of using the directly this error field, what we can do is translate this function, and we need to pass our translator, the English translator which we have. If you have defined more translation, then you can simply add the other translator over here. Now let's try to rerun and see if we have got any better error messages. Super, like these are much more better readable error messages. It says confirm password is required field. Date of birth is all of them are like required field. Now let's try to provide the fields over there. Let's say name is Ankit. Let's email. Let's give it as XYZ for now. And then add password as 123, call it. Again, we have got a validation error, like confirm password we have not given, so it's required. The email must be valid, the password must be at least 7 characters. So it started giving us the validations errors for each of the rules which we have defined. So if I'll pass the confirm password as same as 123, it will stop giving me those errors. And we need to pass our other fields as for gender, it is not giving error because we have not defined the rule now. So let's pass gender as male, date of birth, which will be 29th 05 1903. Any date, like you can just pass it for the testing purpose. And now let's see what do we else left. Now we have email and the password. It says the password should be of length this much, 674567, and email, let's say I'll put my email ID as sanket.kr@gmail.com. All right, now we are good. We have passed all the details, and only then our user will be created with a successful response. If we miss any of these requests, then we will be failed. So I have made a mistake for the gender male. So yeah, now we are good. Other things which we can do over here is we have to verify our password in a better way. Like this is a very weak password, like anybody can identify this. We should be having a check like user should put a strong password to make your application stronger. Now further on, what we can do over here is to define a custom validation rules. For example, for the password field, we want to restrict the user to not set the weak passwords. It should have at least some small case or uppercase or a special character it should have. So let's try to define that. Let's go to our sign up go file. And over here, we'll be defining a new validation rule. Let's see, it should have a strict password. So to define this particular custom rule, we will have to define in our validations, like need to register this particular tag into the validator, and then we will also have to register the same thing into our translation, like define our custom assets for that our custom tag. So to do that, let's name it that register validations, kind of like function which will be calling register validations. Okay, and over here we can just simply, like, this will be a function private to this particular file itself, or we can just have into another file also. Validations.go. Package name should be verifier. In the same package, we can just simply define our function over here. We can just reuse the global variables which we have defined within the package, and we don't have to pass all those variables. You can pass it them as well, like if you just want to specify explicitly, but that's not mandatory. Over here, we can have multiple functions to register multiple custom tags. So to do that, let's register. So to register strict password, let's name it as register strict password tag. Let's define the tag name over here, strict password tag equals to strict password. So this will be like, can be defined at one place, and then we'll be just reusing it. Now to register this particular tag to the validator which we have defined, which is verifier, and then we need to just register validation and the name of the tag, which is strict password tag, then the validator function which we will be defining over here. And yeah, that's pretty much. So over here, the validator function, we will be getting the validation rule for which the field and the value of that particular field will be matching, comparing those fields, and then set the rules. In this case, we'll be setting a regex, and if it succeeded, then we will be sending the results back, the boolean. If it succeeded our math expectation, it will send true, otherwise it will fail. Then we don't have to define anything, call validation, even if null. This validator is not important, so yeah. To get the field value, we can get it from this field level, which can be from the field, and this particular thing will give you the name of the field, and then if you convert into a string, then that will give you the value of this particular field value. Now, if you have the value, you can simply run your regex or any other comparison if you want to do, and then we will be simply returning it. So to do the regex over here, we will be using a regex library from Go standard library itself, and we will say must compile the regex, which we'll be defining over here, and then we will be saying that match a string, the string which we have got from the value. And yeah, that's pretty much. Now it will do the regex validation on this particular field and return it. Now the password matching regex, this is a bit like trickier one, which I have used earlier also. Let's go to get the password match. To get the regex expression, let's go to regexer site. Let's try to define our password regex over here. Let's name it as 1, 2, 3, 4. Our regex should be starting from, it should check from beginning and end. And now what do we actually want? We want our password to be matched only when it has a number, a letter, a capital letter, small letter and capital letter, and a special character. Okay. How can we do that? There's one of the simplest way which I have identified is using like matching the password like what we have. If it does not match, that means we are good to have it. So if it matches what we have, which is like a number between 0 to 9, and it can have any values. So if it has this particular thing, it means it will match our case. And if it does not match our case, that means there is something wrong. So it can also match with A to Z. So if it matches with the small letters of A to Z, like if it matches this one or this one, so we need to provide like at least 0 or 1. So in this case, like it is matching to this particular thing. That means it is matching to this one, that we are good. Now you see, if I put a number, that means it is not matching. So to do that, what we can do, if either this one or this one, like if it does not have a 0 to 9 characters, it should match. And if it does not have these two particular things, it will match. So if I'll put only S, that means it does not have a this one, that means it is matching. And if I'll put only the numbers, then it will also match. But if I'll put them together, then it will not match. So that's where like our condition is getting satisfied. So similar way, what we can do, we can define for A to Z the capital letters, and then we will also do it for the spatial character. The spatial characters is something like which is not there except all of these things. So if we have 0 to 9, A to Z, and A to Z, small letters and capital letters. So if it has anything all these things, then we should also get a match. So now if I'll type capital B and a special character, so now it won't match. And if it does not have any of these things, then it will match. So if I'll type anything with this kind of things, it will match all of them. But if I'll just type a single character, spatial character, then it won't match. And this is the perfect regex for our case. What we will be doing is we'll be matching to this particular regex. And if it does match, that means that's a good case, but not for us. Like if it match, that means it's a weak password. But if it does not match, which is in case only in case of we have all the conditions satisfied. Okay, yeah, I have not provided the plus over here. That's the reason it was not taking the capital B. All right, now we should be good. All right, and we will be just reverse the role over here, which is because if it does match, that means we have a low password and we should be fail on that particular condition. Next thing which we have to do is the add the translation message for this custom tag which we have defined just now, which we can do by verifier dot register translations. Yeah, and the tag name again, it will be strict password tag. The universal translator function, which is translator, which is being defined in our main verifier file, and the register function. So this particular function is actually defining the template for our custom message, which we can do by ut.add, and then over here we need to specify the type. It should be strict password tag, and then the template string. And the last thing which we have to pass is, do we need to override it or not? And then we just simply need to return this function. And then we have to create another function which is actually getting the field of errors. That means like we'll be getting the field value over here and passing it to the translator. This function will get those values and pass it, like glue it with the our template, and then pass the strings. So now over here, from the universal translator, we will be calling our translation function, which is t. This ut should be from the like package, it should be coming, and then the translation of this message. So over here, the tag would be the strict password tag, and from the field error, we can have the name of our tag. Like from this error object, we will be having the name of the field which will be passing. If you want the params to be to also be passed, then we can just simply call fe.params. So whatever the numbers like you will be passing, that will be available to your template over here. So under the template, what we can do is, if you pass like the placeholder to the placeholder, so whatever the value you are passing from here will be passed to your template over here under the as per the sequence of the fields you're passing. So if you're passing fe.params as a second parameter, then that will be available on the second placeholder. So this way, let's start from 0. All right, so but we need only the first one. So this one is the name of the field which says password, and we can define our custom message as must contain a digit, a small case letter, a capital letter, and a special character. Must contain at least a digit, a small case letter, a capital letter, and special character. And this we can just return. It will form the string and then pass it over here. It is throwing an error because it is returning a string and an error. So what we can do is, let's take the translated message, and if there is any error over here while translating, which is not really required, like we have to test it and then we can simply ignore this, like it's not that much of thing is required. From here we'll be just simply returning the translated message, and yeah, that's pretty much, we will be calling over this function from here. If you have like multiple custom tags available, you can simply define your own custom registering the tags over here and then call it one by one over there. Now let's just check whether we are just calling it over here or not. Yes, we are calling it, and yeah, that's pretty much Let's test this out now. Close our server and rerun. And call it. Okay, now we are getting our validation error. It says password must contain at least a digit and all those things. So let's convert our password to a strong password. It says 123 and QWERTY QWERTY, and it should have a capital letter and a special character. So if it has all those things, then we should be good. We should be having a matching password, and then we are able to create. Now, if we just remove the special characters, it will fail. So it requires only a special characters. Or even if we remove the numbers, then also it should fail. But if we just add a single number also, then we are good. All right, this is it. What else I can have over here? If you want to like register multiple languages, you will have to create your multiple translations over here, and then you can add the translations and register your tags over there. So what are the steps you have done for single English translation? You have to do all the steps for the multiple languages. And further on, when you are getting actually validating, you will be expecting a language variable over here. And then as per the language, you have to pass your translations. If French is being selected, then you will pass the French translator over here, and then your error message will contain the French error messages. Other things which I can tell you over here is regarding, you can also get the params values. So for example, if you are setting any uh, values over here, like custom values, for example, like min equals to 7, or if you want to specify something like strict password, and you can say medium over here is being allowed, and the other option, it could be high. So these two options you can provide, and over here in the regex, what you can do at the time of validating this, you can get the param value over here by using fl dot params, and now you will get the value as medium or high, and based on that you can create your two different set of regex or matching things and then return accordingly, and accordingly you can set up your checks over here. Then we are good. So this is pretty much with the validations. I'll see you guys in the next video now. Thank you so much for staying so long.